In this video, I'm going to go over how we name ionic compounds using the stock system. The stock system uses Roman numbers, and the Roman numbers apply only to the metal ion that's being used. It's a transition metal. So I'm going to go with the example from slide number 27 that I started with, Fe2O3. How would you name this compound? Well, what we've been practicing is that you would name the first element, iron. Its name wouldn't change. The second element would take on an IDE ending, oxide. But this name is incomplete because we need to tell which iron we used. Did we use Fe with a +2 charge, or did we use Fe with a +3 charge? And that much we need to figure out. So either we put the Roman number 2 or the Roman number 3 to indicate the charge on the transition metal. And I'm going to show you how we can figure that out working backwards using those oxidation numbers. So here's the formula, Fe2O3, and we're not sure what to put for the charge of iron. Do we put +2 or do we put +3? But for oxygen, we know that its oxidation number is -2. We figured that out because if we remember, in the last unit we learned that oxygen has 6 valence electrons and it needs to gain 2 more in order to get an octet. So that's where the -2 comes from, the fact that it needs to gain 2 electrons. Let's just erase that, get that out of the way. Okay. If we divide the whole compound into the negative part and the positive part, let's start with the right side because we know what we have. We have -2 for each oxygen, but we have 3 oxygen atoms. That's what the subscript tells us. So -2 times 3 gives us a net charge of -6. What I know over here is that the net charge of the iron must cancel out the -6. In other words, the +6 and the -6 must equal 0. You learned that on slide number 18, that the sum of all the oxidation numbers must equal 0. What that really means is that the net positive charge and the net negative charge, they have to add up to 0. They have to cancel each other out. So now if we go back over here, I know that I have 2 irons. And what should I plug in, +2 or +3? Well, 2 times what would equal +6? +3 works. 2 times +3 multiplies up to +6. So what do I want to put here is +3. Now that I figured out I use the +3 ion, the name of this compound, Fe2O3, would be iron, Roman number 3. Oh, that looks bad. Let me rewrite that. Roman number 3, oxide. Anyone that's reading this name understands that it was the Roman number 3, it was the iron +3 that I used to bond with the oxygen. What if I had iron Roman number 2 oxide? What would that formula look like? Well, now it's easy. I've given you the Roman number. I know that that's Fe. The Roman number tells me +2. Oxide is still oxygen with a -2, and when I crisscross, bring them down, drop the charge, and simplify, what I'm left with is just FeO. A very different formula. So iron 2 oxide and iron 3 oxide are 2 different compounds, different colors, different properties, everything about them is different, and that's why they have different names. So I'm going to give you a few examples to practice. I'm going to give you copper 2 chloride. And I'm keeping it simple. I'm giving you simple binary compounds, no polyatomics right now. So copper is Cu. The Roman number tells you it's +2. And chloride, it's a group 17 nonmetal, which means it has 7 valence electrons, and it needs 1 more to complete its octet, so it's a -1 ion. Crisscross, bring them down, drop the charge, and simplify, you get CuCl2. Now let's work backwards. I'm going to give you a formula, you give me the name. This is the hard part, working backwards. Now, if you look up sulfur, sulfur is a group 16 nonmetal. Just like oxygen, it has 6 valence electrons. It needs 2 more to complete its octet, so it makes sense that it's a -2 ion because it needs to gain 2 electrons. So, I have 2 sulfur, each at a -2, a net charge of -4. I want the +4 to be my net positive charge, and I only have 1 manganese. What charge should the manganese have? 1 times what equals +4? You got it. +4. So the name of this compound is manganese, Roman number 4. For those of you that don't know your Roman numbers, V is 5, and when you put a 1 to the left of it, that makes it 4. And the sulfur atom takes on the IDE ending, sulfide. Seems like a lot of work, but you've got to practice it and make sure that you've got all the steps down. So I'm going to give you another example, and this time I'm going to throw in a polyatomic ion. So instead of looking to the reference table and thinking about whether or not the element would gain electrons 2 or 3 or 4 or 1, I want you to go to reference table E. When you go to table E, I want you to look up sulfate. And you'll see SO4, and you'll see a -2 charge. That -2 goes right here. So again, we're looking at 3 sulfates, each with a -2 charge. The total net charge is -6. That means we want a total net charge of +6 over here. We have 2 cobalts times +3. So cobalt +3 is what I used, because +3 times 2, -2 times 3, the net charges add up to 0. So the name of this would be cobalt, Roman number 3, sulfate. One more example? Okay. Take a moment, think about it. Divide the compound in half, your positive and your negative. Let's move it over to the center. Go to table E, look up the carbonate ion, and what you'll see is that it has a -2 charge. Now this one's really tricky. There were no parentheses around the carbonate. I only have 1 carbonate here, not 3. Be very careful. I've got 1 carbonate with a -2 charge. My net charge is -2. It's very common for students to think that that 3 applies to the whole ion. But remember, when there's no parentheses around the polyatomic ion, I only had 1 of them. And I only have 1 nickel. So 1 -2 carbonate means 1 +2 nickel. The net charge +2 and the net charge -2, those net charges add up to 0. So the name of this compound is nickel 2 carbonate. That was a nickel with a +2, a carbonate with a -2, and when I crisscross, bring them down, drop the charge, and simplify, what I'm left with is a 1-to-1 ratio, nickel carbonate, nickel to carbonate. Continue practicing. There are worksheets in the classroom, and come see me if you need help, but this does require a lot of practice. Good luck.